Hey everyone, this is a quick attempt to give you some insight into the two Khan Academy practice sets that are kind of linked together about what is often called straight line motion. Imagine there's like a railroad car on a track. The track is just moving left and right. There's no like vertical positioning on this. So if this is the car at the origin and it's moving this way to the positive, we're going to represent it as vertical movement. So this is moving to the right in our straight line motion. This is moving to the left, that's negative, and this is time. So we're not talking about movement in space on planar motion. We're talking about just railroad track kind of motion. All right, so the position function, this is S of t, looks like it's starting at 0. This boxcar, the railroad car, is moving away. It's gradually getting faster. It's gradually moving in an increasing amount of right-hand motion. And then at this moment, the position tells us that that car is not moving any further. It's in fact turning around and moving back towards where it started. Here's where it began at the 0 position, and then it moves to the left, and then it sort of slows down moving to the left, and here, based on the position, we can see that it stopped. So the first derivative of the position is the velocity, and so we should just strictly focus on what is the slope of our tangent line here in green. So it's lower but positive. It's more and more and more positive. It's increasingly positive until it gets to about here when it's slowing down and stopping. So the velocity slows down and stops. Because why? Because that is a horizontal tangent right there. Okay, so we know that directly below there should be a 0 for the velocity. Just like right here, a tangent line is near horizontal, so it should be a 0 for velocity here. It's moving in a left direction, so that's why it's a negative velocity there as it goes downward. The acceleration then is the derivative of the velocity. It's more or less uniformly straight here, so we have more or less uniform acceleration here. Then as the velocity changes, the acceleration has changed as well. And of course, according to Newton, it's the acceleration that changes the motion rather than sort of the other way around. But we can look at these three graphs and then, understanding what this all means, answer the questions here in the Khan Academy practice set. Notice that this is the velocity. So it's as if we're looking at the red graph over time, and we can then answer, is it moving forward, backward, or neither? So pretty straightforward. I need to click out of this to answer the question. So this looks like it's 0 velocity, so I'm going to say that's neither. This looks like this is the velocity is moving most rapidly in the left-hand direction, so I'm going to say it is moving backward, and this is moving most rapidly in the forward direction. That is the maximum velocity right there, moving forward, and this is also moving backward, just less so than before. Okay, so just remember, this is the velocity graph. That is a critical thing not to get mixed up on. Hopefully I'm correct. Yay. All right. Now here we've got, pay attention, again, this is velocity up here. So I am moving towards the right, and am I speeding up? Well, remember, the velocity graph is all about the increasing or decreasing. If my velocity is increasing, I am speeding up. All right. Here, I am on a cusp. I am neither speeding up nor slowing down. Looks like I've made a very abrupt change to go in the left-hand direction. And in this case, I am slowing down. My velocity is going to the right. I'm still moving to the right, but I'm going less and less quickly to the right. And it looks like this, I am speeding up because I am moving more and more and more quickly to the left. Here we go. All right, last one. This now is a position vector, so I'm not going to get fooled into thinking it's a velocity vector. The position is the object moving forward, backward, or neither. Well, if it's a rail car and if I'm moving, right, the velocity is going to be about the slope of that tangent line. So even though my rail car is at a position 0 it seems like it is very clear that it's moving towards the right because my position was on the left-hand side, passing through the origin, moving towards these other dots here. So I'm going to be moving forward. Here, it looks like I am also moving forward. My position, my slope is positive, moving forward. And this one, even this one, I believe is moving forward. So we're just not going to get fooled into thinking, whoa, I almost missed that one. What's this one doing? This one, my position was here, and my position is always moving closer and closer and closer to the, or moving towards the right. That is moving forward. So there we go. Hope this works. Yeah, okay, now I'm going to move on to the other practice set, which is in our Sync Day link. So if I click on that, it should go there. Khan's doing a background check, seeing if I'm approved for this one. Thanks for your patience. These are slightly different but related. I think we're going to get some actual equations on this one, so we'll see how it works. This might take a little bit longer. I'll just do one of these. Here we go. Thank you. Thank you, Sal Khan. All right, so the particle moves along the x-axis. The function x of t, that's like our s of t, it's position function, and this is t greater than 0. So there we're given, what's the particle's velocity at t equals 2? So all I need to do is the derivative, right? So I'm going to take the derivative v of t then. I'm sorry to have to make you watch me write this. Very bad handwriting. It's going to be 6t squared and then minus 8t minus 8. And what it's asking is, what is the particle's velocity when it's 2? So if I plug in 2 there, 4 is when I square it, then times 6 is 24. When I plug in 2 here, I'll get minus 16. That gives me 8. And when I take away 8 more, I'll be at negative 16. So I'm going to type in negative 16. And then what is the direction of the particle's motion at that point? So the velocity is negative, so it is moving to the left. Okay, fairly straightforward. There are some that will deal with, I believe, acceleration, and you have to be able to do both derivatives, but it's very, very similar to the curve sketching we did.